Black holes are one of the most fascinating and mysterious phenomena in the universe. They are enormous entities with a mass between 2 and 4 million times that of the Sun, but at the same time practically invisible to us. Until recently, we knew very little about them, but thanks to research over the last 2 decades, we have learned more and more about these enigmatic objects. Recently, Michio Kaku announced a momentous discovery: we have managed to find out what lies inside a black hole. This new information has illuminated details that might have gone unnoticed in the scientific world. We have delved into black holes and revealed the secrets of these mysterious spaces. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, and turn on the notification bell. Although many of us have a general idea of what black holes are, there are still some gaps in our knowledge. In 1916, Albert Einstein published his theory of relativity, which predicted the existence of black holes. At that time, the concept of black holes was purely theoretical. It was necessary to wait another 50 years for the scientific community to find evidence of their existence. In fact, this event occurred in the 1960s when scientists were studying the constellation Cygnus. During their observations, they noticed a bright blue star emitting X-rays. They discovered that these X-rays were not moving on their own but were attracted to a giant black object around which the star was orbiting. This is how the term black hole was coined. This discovery was significant because it provided concrete evidence for the existence of black holes, demonstrating that they were not merely fragments of Albert Einstein's imagination. It also revealed the existence of an incredible entity in space that we urgently needed to investigate. This black hole was named Cygnus X1 and is located in the constellation Cygnus at a distance of approximately 6,000 light-years from Earth. This was no small discovery as it had an incredibly high density, which gave it a strong gravity. Scientists undertook the search for other black holes and discovered that there could be around 100 million of them in our own galaxy, the Milky Way. However, due to their extreme difficulty in detection, we still do not have a precise number. It appears that there are several million black holes in our galaxy, which makes them very important objects of study. The main concern with black holes has always been their gravitational attraction, so intense that anything that enters them will be astronomically compressed into a singularity. Black holes act like cosmic vacuum cleaners, sucking in everything in their path. One of the most disturbing parts of black hole research is the fact that if someone were to fall into one, they would be stretched to the point of becoming a single line. This process would occur slowly, and the person would die before the final form is established. Therefore, it is safe to say that no one should venture into a black hole. However, since these objects are present everywhere, questions and concerns arise as to whether we are really in danger. Even though the closest black hole to Earth is 1,500 light-years away, which is still close enough to raise questions and concern. In 2021, scientists managed to publish the first clear image of a black hole, specifically of the black hole M87. For several consecutive nights, photographs of the black hole were taken, and with each image, researchers collected more evidence about it. It was necessary to combine the individual photographs to obtain a complete image that filled in all the gaps. In this way, the scientists discovered that black holes are not simply an empty hole in the void as many people believed. In reality, they are much more complex. To reach the empty part of a black hole, 3 previous layers must be traversed. The first layer is known as the event horizon, which is a point of no return. Once the event horizon is crossed, there's no turning back. The second layer is the photon sphere, which is the region where light orbits around the black hole. Any light entering this region will be trapped and will not be able to escape the gravitational pull of the black hole. Finally, the third layer is the singularity. This is where everything that enters the black hole is astronomically compressed into a point of infinite density. The singularity is a point in spacetime where the laws of physics as we know them break down. You're probably wondering what lies beyond the third layer called the singularity. The idea is that instead of being crushed by falling into a black hole, one would be sucked through a tunnel through the ring of fire and emerge through a white hole somewhere else in a parallel universe. This tunnel is known as the Einstein-Rosen bridge or wormhole. This theoretical bridge is a passage through spacetime that connects 2 separate regions of the universe or even 2 parallel universes. To understand how this works, we must understand the concept of spacetime in Einstein's theory. According to this theory, space and time are not separate entities but are connected, forming a four-dimensional fabric known as spacetime. Objects with mass warp spacetime, creating a gravitational field that affects the motion of other objects. To visualize this, we can imagine a sheet of paper representing spacetime. If we place 2 points onto the paper and draw a line between them, we are representing how objects move through spacetime. Now let's consider folding the paper in half and creating a shortcut between those 2 points. This basic idea is what is known as a wormhole. It is a shortcut or connection through spacetime that joins 2 distant points in the universe. Although wormholes sound like science fiction concepts, they are actually a prediction of the theory of general relativity. So far, however, none have been directly observed. The reason for this is that wormholes are inherently unstable and would collapse almost instantaneously. However, if a stable Einstein-Rosen bridge existed, it would mean that black holes are not only cosmic devourers but also portals that could connect us to other regions of space-time. The question then arises whether we could use a wormhole to travel through space and time. Although this is still the subject of speculation and its feasibility has not yet been demonstrated, the theoretical possibility of wormholes opens the door to exploring fascinating concepts about interstellar travel and the connection between different parts of the universe. What do you think about it? Do you think wormholes are a mere speculation? I hope you liked the video. If so, don't forget to hit the like button and subscribe to the channel so you don't miss more content like this one. See you in the next video, and thank you so much for watching.